Welcome to the Animated Engineer channel. In this explainer video, we will explain what is a hydrostation, how it works, its advantages, and some real-world calculations on power flow. Before jumping into the field of electricity generation, we might do a recap on where electricity came from. Michael Faraday first discovered electromagnetism in 1831. Faraday was inspired by the work of Hans Christian Ørsted, who in 1820 discovered that an electric current could create a magnetic field. This led Faraday to ask the reverse question: could a magnetic field create an electric current? Michael Faraday devised a brilliantly simple experiment to explore electromagnetic induction. He wound two coils of wire around opposite sides of an iron ring. The first coil was connected to a battery, the primary coil, while the second was connected to a galvanometer, the secondary coil. When the battery was connected or disconnected, the galvanometer needle briefly deflected, evidence that a current was induced. This demonstrated that it is a changing magnetic field, not a static one, that generates an electric current in a nearby conductor. This principle became known as Faraday's law of induction, forming the foundation of modern electromagnetic technology. Fast forward to 1882, the Appleton hydroelectric power station became the world's first hydrostation, operating with direct current, DC electricity. Just a few years later, in 1886, the Great Barrington Hydro Station became the first to generate alternating current, AC. With 25 horsepower motors and estimated generator efficiencies of around 60 to 70%, its output was between 11 to 13 kilowatts, enough to illuminate 36 incandescent lamps across several buildings in the town. This milestone showcased the viability of AC transmission over longer distances. These innovations ignited the fierce electricity wars. On one side stood Thomas Edison, championing DC and backed by financier J.P. Morgan. On the other was Nikola Tesla, who promoted AC technology and was supported by George Westinghouse. The rivalry was intense. Edison went to great lengths, including public animal executions, to portray AC as dangerous. Despite this, AC eventually triumphed due to its superior ability to be transformed to high voltages and transmitted efficiently over vast distances. Now that we've taken a quick glance at the history, let's dive into the calculations. First, let's examine the basic model. The dam holds back the water, creating potential energy. When released through the penstock, the flowing water drives a turbine located at its end. This mechanical motion powers a generator, which then converts the energy into electricity before the water continues its path into the river. To calculate the potential energy, we will use the following calculation: mass times gravity times height. Since the mass of water is equal to 1,000 kilograms per 1 meter cubed, the gravitational acceleration is equal to 9.81 meters per second, and we will select a height of 50 meters. Subbing this into the formula, the potential energy equals 490,500 joules. Now that we've completed the basic calculations, let's shift our focus to a real-world example using data from the Inniscarra Dam in Cork, Ireland. The dam has a head height h of 45 meters and a flow rate q of 29 cubic meters per second. With an efficiency eta of 90%, a water density of 1,000 kilograms cubed, and gravitational acceleration of 9.81 meters per second squared, we can apply these values to our formula. The resulting power output is approximately 11,521 kilowatts. At this capacity, the dam can supply electricity to around 7,681 homes. When operating at full potential, it can provide power for up to 12,666 homes. Looking at the world's largest hydroelectric station, the Three Gorges Dam in China, it was commissioned in 2003 after nearly a decade of construction. With an installed capacity of 22,500 megawatts, it generates enough electricity to supply around 15 million homes, depending on the after-diversity maximum demand values applied. Now let's take a look at some key advantages. Hydroelectric power is a renewable energy source known for its reliability, low operating costs, and potential for energy storage. On the flip side, the disadvantages include a high initial construction cost, extended build time, ecological and human disruption, potential flooding, risk of dam failure, and reliance on consistent rainfall.